Hey everybody, it's Miss Berry. In this video, we're going to go over section 5.1, which is called Polynomial Functions and Polynomial Inequalities. We've already talked a little bit about polynomials, and we know that polynomials are mathematical expressions that consist of variables and coefficients. And we know that the exponents in polynomials have to be positive whole numbers. All right, so polynomials, we're going to be working with some polynomial functions. We'll talk about some properties of polynomials and some characteristics of polynomials, and then we'll look at polynomial inequalities. So as you already know, inequalities involve things like, let me see if I can get my pen up here. Inequalities involve things like less than, greater than, or less than or equal to, or greater than or equal to. All right, so first we're going to talk about the zeros of a polynomial. The zeros of a polynomial is just a fancy name for the X intercepts. Whoops, let me try that again. So they are the X intercepts of a polynomial. Also sometimes called roots. And basically, whenever you plug in these numbers, they give you back a 0. So the output is 0 when you plug in an x-intercept. Determining the zeros, you can do that in many ways. You can do it graphically or what we're going to call algebraically. So we'll talk a little bit first about how you can do this graphically. So make sure you have your graphing calculator out. We're going to look at a polynomial. And it says, solve the following polynomial equation by factoring or using the quadratic formula. Identify all solutions. We're going to just ignore these directions, and we're actually going to we're going to solve this equation by graphing. So I'm going to show you how you can do this in your calculator, if you so choose. I do not care how you find the zeros. If you want to find them graphically, that's fine with me. If you want to find the zeros algebraically, that's fine with me too. So again, finding the zeros of a polynomial, same thing as finding the x-intercepts or finding the roots. And it's also the same thing as solving the polynomial equation. All right, so we're going to take our equation, just the left side of the equation. So we're going to take the left side of the equation and we're going to plug that into our calculator. So go ahead and get out your calculator. All right, let me see if I can get this the way I want it. There we go. All right, so it's kind of hard to read there, but hopefully you can see that polynomial. We're going to go to our y equals screen right here. So we're going to go right here to our y equals screen. And we're going to type in our function. You can see the variable x is right here. It's by the alpha button. So we're going to hit x. We're going to hit the caret down here, the very bottom of my screen. See if I can point at it better. There we go. So the caret to the third power. Go ahead and use the arrow to get out of the exponent. Minus 27x squared plus 26x. All right. Now you're going to go ahead and let's check your window. I like to start in the standard window, which is -10 to 10, -10 to 10. If you're not in that standard window and you want to easily get to it, you just go to Zoom and go to Zoom Standard, which is option number 6. Z Standard, that puts you in the standard window, -10 to 10. That's where I like to start. Now this is a third degree polynomial, which means it should have 3 solutions, or at most 3 solutions, but right now I'm only seeing 2. So the solutions are where it crosses the x-axis. So it looks like we might need to move our x-axis this way so we can zoom out a little more, so we can see that last solution. So let's go to the window, and we're going to move our x max. X is the horizontal axis, so let's move it to, let's say, like 50. All right, so there we go, 1, 2, and there's the third one. So it looks like we way overshot it, so maybe we'll cut it back to like 30 so we can see it a little bit better. So just moving my x max to 30. See how that looks. 1, 2. And here comes my third one. There we go. Right, so there are my 3 solutions. It's where the graph crosses the y-axis, or excuse me, the x-axis. So to find these spots, you can use your calc function in your calculator. You can see it right there. So we're going to go to second trace, and you're going to go to the zeros. So remember, the solution of a polynomial, the X intercepts, the roots, the zeros, they're all the same thing. So we're going to go to 0. It's going to ask me a few questions. It wants me to get left of the 0. So let's see. It says right now I'm at x equals 10, so that's somewhere out here. So I need to move up. So I'm using the left arrow. Oh, I think I just passed it. There we go. All right, so I want to get to the left of that little 0 right there. It actually ended up telling me what the 0 was. That was kind of nice. So it tells me there's the 0, 0, 0. That was just lucky. So I'll show you how you actually do it. So get to the left of it. It looks like we're to the left of it now. Hit enter. And then you want to get to the right of it. We're to the right of it now. So hit enter again. And it wants you to guess. So just move it right there to our guess. And there's our first 0. And we only care about the x value. So we have x equals 0. Yeah, x equals 0. So we're solving for x. So we only care about the x value. We know the y value's got to be 0 because we're on the x-axis. So there's our first solution. Let's find the next one. So we're going to go second trace again. Go to 0. So this time we're trying to find this 0 right here. So we're to the left of it right now. So I just hit enter for the left bound. Get to the right of it. So now I'm to the right of it. Hit enter again. Now I guess. So that's pretty close. So we'll hit enter. There's my second 0, x equals 1, for my second solution. All right, and then we're going to do it the third time for this third 0 over here, the third solution. So second trace takes us to the calculate menu. All right, so it looks like we're definitely to the left of it. See if we can get a little bit closer. Just trying to move it until I see it down here. Just keeping on going. We're getting close. We're closer. Just going to hold it down. You can see it's way down here at -2,000. It's going back up now. Look, it's getting closer and closer to 0. Whoa. Where'd I go? Went too far. Have to be careful here not to overshoot it. All right, so it looks like I'm in the negatives right now. I'm just going to go until I get close to 0. Oh, okay, so that's the closest I'm going to get to 0 for my y. All right, so get to the right of it. So we want to get positive above the y-axis, so that's positive. Then a guess. All right, and there we go. There's our last 0 is x equals 26. So that's how you can solve a polynomial graphically. this is not how I find the polynomials, or excuse me, find the zeros of a polynomial or the solutions of a polynomial, but this is a totally fine way to do it. There's nothing wrong, nothing wrong with doing it this way if this is how you prefer. So next I'm going to show you how to do it algebraically or by hand. Let me see if I can add in another example here. All right, so this will be a little extra example. We'll say find the solutions of the polynomial. All right, so we'll do, trying to find a good example in the textbook. All right, so we'll do this one. X cubed minus x squared minus 6x equals 0. So this is how you do it algebraically. So when I look at this, we're going to use the method of factoring. So when I look at this, the first thing I notice is that there's an x in every term. So I'm going to go ahead and pull out an x. That's going to leave me with x squared minus x minus 6 equals 0. Now I can go ahead and split these up, set this first piece equal to 0, set the second piece equal to 0. There's one of my solutions. Okay, now I'm going to factor this. Let's think of factors of -6 that would add to -1. Let's see, what would that be? Negative 3 and 2. So x minus 3, whoops, x minus 3, x plus 2. Yeah, those would add to, oops, -3 and +2. Those would multiply to give you -6 and add together to give you -1. All right, so set each piece equal to 0. Sorry, I keep hitting the button on my pen. So we get x equals 3 and x equals -2. So there's my 3 solutions. So that's how you do it algebraically. If you ended up you couldn't factor it, you could always use, once you got down to this part here, you could use the quadratic formula. Remember, quadratic formula is only for quadratics, so things that have a highest exponent of 2, polynomials with the highest exponent is 2. So you could use the quadratic formula from there if you wanted to. All right. Next, I'm going to talk about what it goes by a lot of different names. Sometimes it's called the leading term test. Let's see. Sometimes it's just called the behavior of polynomials. I'm going to call it the end behavior table. But before I go and look at the end behavior table, I need to remind you of a few terms. So recall that the degree of a polynomial is the highest exponent. So it's the highest exponent of the polynomial. The leading term is after you write the polynomial in descending order. It's the first term. First term. And then the leading coefficient is the coefficient on the first term after you've written it in descending order. Okay, so let's look at the end behavior table. Definitely going to want to pause the video and copy this down or take a screenshot of it and save it somewhere. All right, so this is the end behavior table. So go ahead, like I said, and pause the video or take a screenshot so that you have this table. I made this table so it is not out of the textbook. So this table has 4 boxes. You can see that the columns here designate that the degree of the polynomial is even. Here the degree of the polynomial is odd. The top row is for when you have a leading coefficient that's positive. The bottom row is for when you have a leading coefficient that's negative. And this tells you what's going to happen at the ends of the polynomial. So if the degree is even and the leading coefficient is positive, the ends of the polynomial are both going to be going towards infinity. So you can see as x goes this way, the polynomial is increasing towards infinity. As x goes to positive infinity, the polynomial is still going towards positive infinity. All right, so here, if you go to the left, so as x gets closer and closer to negative infinity, the graph is going down to negative infinity. Looks like we have a mistake in our table. Let me fix that. This should be negative infinity. And this should be positive infinity. Okay. Sorry about that. We'll be careful as we go through. Yeah, it looks like some of these are messed up. I copied this part from another end behavior table and I didn't check it. All right, so we'll just be careful here. Let me fix this first and then, goodness gracious. I'm going to try to make this look nice. Let me fix the infinities. So this one. Okay. All right, so it's fixed now. Sorry about that. I'll fix it and post a corrected end behavior table on D2L. All right, so let's start back and look at this polynomial. It says whenever your leading coefficient is positive and the degree is odd, as you go towards negative infinity, the graph is also going to go down towards negative infinity. But as you go towards positive infinity in the x direction, the graph is also going to increase. Here, as you go towards negative infinity in the x direction, the graph's going down. As you go towards positive infinity in the x direction, the graph is going down as well. So they're both going towards negative infinity. And then here, as you go left in the x direction, so towards negative infinity, the graph is increasing towards positive infinity. And as you go to the right in the x direction, so x is increasing, it's going towards positive infinity, the graph is actually decreasing, going towards negative infinity. Okay, so we use this table to help us figure out what the graph is going to look like for complicated polynomials. So all we have to do is make sure the polynomial is in descending order, identify what the degree is, identify if the leading coefficient is positive or negative, and we can get an idea of what the graph will look like. All right, so let's look at some examples where we're going to use the end behavior table. So this is, let me see. This is technically number 2. It says, consider the following polynomial. F of x equals negative 8x squared plus x plus 18. Find the degree and the leading coefficient of f of x. All right, so make sure it's in descending order. we have the highest term first, then the next, and then the next. All right, so we can see that the degree is the highest exponent. It is 2. The leading coefficient is -8. And let's just think about what the graph would look like. So we have an even degree. This is an even degree and a negative leading coefficient. So even negative. So even negative tells us that the graph is going to be pointed down. So we know the graph is going to look something like that. Okay. Let's look at another example. This is number 3. Oh, well, that was what we just did. It said describe the behavior of the graph of f of x as x increase, or as x approaches positive and negative infinity. So this arrow here, we read it as approaches. Excuse me. All right, so what they want you to do in the homework is they want you to write down this stuff down here. So we know that the graph is pointed down. So that means as x approaches negative infinity, so we're going in the negative x direction, so that way the graph is going down. So f of x is approaching also negative infinity. And then as x approaches positive infinity, so as our x's are going this way, so as we're getting closer and closer to positive infinity in the x direction, our graph is still going down. So f of x is still approaching negative infinity. Okay. Maybe it'll help if I put a little coordinate plane behind here. Okay. All right. So that's what they want for describing the behavior of a graph. Let's look at number 4. This one says, identify the correct graph and the x and y intercepts of the polynomial function. Express all points as ordered pairs. All right, so here we have a polynomial s of x equals x squared minus 2x minus 8. So this has an even degree. You can see it's already in descending order. So degree is even. Leading coefficient here is 1. So leading coefficient is positive. So if you go back and look at our table, even positive means the graph's going to go up, concave up. So it's going to look something like this. So we can automatically eliminate these bottom two. They are not pointed the correct way. So now we need to find the x-intercepts, and that will help us, I think, well, actually, we need to find the vertex, right? So this is a parabola. So if we find the vertex, that would help us. Or we could do it using the y-intercept. I think the y-intercept would actually be easier, so let's do it that way. All right, so we know about the y-intercept. We know to find the y-intercept, you just replace x with 0. And solve. So we're going to replace x with 0, so that's x squared minus 2 times 0 minus 8. So 0 squared is 0, minus 2 times 0 is 0, minus 8, so that's negative 8. So we know that it should cross the graph at negative 8. So let's see, negative 5, negative 6, negative 7, negative 8. So that's negative 8. Let's check this one. That's negative 5, negative 6, negative 7, negative 8. Oh, they're crossing at the same point. Also looks like, well, no, look, our y-intercepts, or excuse me, our x-intercepts are different. This x-intercept over here is negative 5 and then 2. So the x-intercepts are negative 5 and 2. And here the x-intercepts are negative 2 and 4. All right, so we need to find the x-intercepts. All right, so let's solve this. So we know that we're replacing y, or in this case, s of x, with 0. And we're going to solve for x. All right, so we're going to factor this. So what are some factors of -8? So things that multiply to give you -8 that add to -2. Let's see, that would be like -4 and +2. All right, so set those both equal to 0. Get x equals 4 and x equals -2. So there we go. There's our answer. So this is the correct graph. That was a challenging one. I guess you could have also just graphed it in your calculator and just matched it up with the graph on the screen. You could have done it that way if you wanted to. This would be like the algebraic way of solving this. So you could have done it graphically just by putting it in your calculator. All right, so next we're going to talk about polynomial inequalities. So polynomial inequalities are pretty challenging problems. You could, in theory, you could graph these and figure out the answer, but I think most of the time you're probably going to have to end up doing this algebraically, just because the polynomials may be pretty complicated. So again, you could do this graphically. Whoops, thought I was on my pen. I'll try that again. You could do this graphically or algebraically. All right, so let's look at the process for solving a polynomial inequality graphically. Let's see, what number is this? This is number 5. It says, find the solution of the following polynomial inequality. Express your answer in interval notation. Okay, so it says we're looking for where this polynomial is less than or equal to 0. So that's below that'd be the x-axis or below. So it says x times x plus 1 times x minus 2 is less than or equal to 0. All right, so we are going to put our calculator up on the screen. Okay. There. All right, so let's go to our y equals screen. Clear that out, so hit the clear button. Type in your polynomial, x parentheses x minus, or excuse me, x plus 1 parentheses x minus 2. All right, then go ahead and graph this in the standard window to start with. So go to Zoom, Standard. So that's option number 6. All right, there we go. This is, if you multiply this out, this would be a 3rd degree polynomial. So we see it's crossing in 3 places. 1, 2, 3. So we've got all 3 of them right here. We're looking for where this polynomial is less than or equal to 0. So let's maybe zoom in on this a little bit so we can see it better. So it looks like in the x direction, maybe we can go to, let's see, it's -1, -2, -3. We'll go from -5 to +5. And then looks like we can do the same in the y direction. So let's go to the window and make it -5 to 5, -5 to 5. Whoops, I hit the wrong thing. Oh, let me go back to my window. I messed up the x scale. Let me see. The x scale should always be 1. Right, so that's supposed to be -5 to 5. There we go. All right. So we're looking for where this polynomial is less than or equal to 0. All right, so if you read the graph left to right, you can see down here it's definitely less than 0. This is the x-axis, so that's where it's 0. So all the way from -infinity all the way to -1. So from, let's write that down, -infinity to -1, it's less than 0. less than or equal to 0. And we're actually going to do a bracket here because we want to include that number 1. Let's do like this, negative infinity to negative 1. So we're including that number negative 1 because that's where it's equal to 0. Here it's above the x-axis, so that's where it's positive or greater than 0. But right here we go back down below the x-axis, so this would be from 0 to, that'd be 1, 2. So from 0 to 2, we're below the x-axis. We're using brackets on both ends so we can include those numbers. All right, so now we just have to connect these intervals using our little union symbol. All right, so this one was pretty easy to do graphically. They're not all that easy to do graphically. Sometimes they're complicated and it's hard to find a good window because they might go off the screen a little bit of your window. I mean, of your calculator, so it's kind of hard to find the correct window. So let me show you how we would do this algebraically. It's a 4-step procedure. It says this is the procedure for solving polynomial inequalities using the sign test method. Step 1 is to find the real zeros of the polynomial, or find the solutions, or find the roots, or find the X intercepts. They're all the same thing. And then it says, step 2 says just place the zeros on a number line, splitting it into intervals. Then it says within each interval, select a test point and evaluate the polynomial at that number. If the result is positive, then the polynomial is greater than 0 for all x's in that interval. If the result is negative, then the polynomial is less than 0 for all x in that interval. It says write the solution set consisting of all the intervals that satisfy the given inequality. If the inequality is not strict, which means it uses less than or equal to or greater than or equal to, then these zeros are included in the solution set as well. Okay. So make sure you write this down or take a screenshot of it and save it in your notes. And let's look at an example. These can be pretty challenging, so we'll take our time. It says, find the solution of the polynomial inequality. Express your answer in interval notation. All right, so we want to get the entire polynomial on one side. And I think I would like to keep this positive, so I think I'll just go ahead and move over this 3x and move over the 4. Okay. So that's going to cancel. You have x squared plus 3x minus 4 is greater than or equal to 0. All right, so it says the first thing I need to do is I need to find the zeros of this function. So I'm going to go over to the side and I'm going to solve this, set it equal to 0 and solve it. So we're looking for factors of -4 that add to 3. So I think we could do x plus 4 and x minus 1 equals 0. Set those both separately equal to 0. So we get x equals -4. It looks kind of like a 9. Let me try that again. And x equals 1. All right, so it says step 1 was to find the zeros or the solutions, which we've done. Step 2 is to put the zeros on a number line and split it into intervals. All right, so let's draw a little number line. Actually, I think I have a button where I can make a line. There we go. Okay, go ahead and place your solutions on that line. So -4 and 1, make sure you put them in the correct order. -4 is the smaller, so it goes to the left. 1 is bigger, so it goes to the right. So here we have some intervals. Here we go from -infinity to -4. We're using greater than or equal to here, so we will have to use brackets. Then we go from -4 to 1, and then from 1 to infinity. Infinities always use parentheses. All right, so our next step tells us to, within each interval, select a test point and evaluate the polynomial at that number. All right, so go into each little interval, and you're just going to pick a number out of this interval. So negative infinity to negative 4, let's just pick, say, like negative 5. You could pick negative 6, negative 7, negative 100, anything that's in between negative infinity and negative 4. I think in this interval, I'll pick something easy like 0. And then in this interval, pick something like 2. I'm just trying to pick some easy numbers to plug in. All right, so let's plug these into our polynomial. This is our polynomial right here. So just that piece. We're going to see if it's positive or negative. All right, so let's get our calculator. All right, so I'm going to hit second quit to get out of that graph. Now I'm going to plug in negative 5 into my polynomial. So negative 5 squared. Actually, let me show you an easier way to do this. Since we have to plug in several values, we can go to y equals, plug this in. So that'd be x squared plus 3x minus 4. Then go over here to the table. Second graph takes you to the table. Let's see, negative 5. That gives you a positive 6. We only care if it's positive or negative. So remember it said if the result is positive, then the polynomial is positive. If the result is negative, the polynomial is negative. So I'm just going to indicate whether it's positive or negative using a plus or minus. So we have a plus in that interval. If we plug in 0, that gives you a negative 4. So that one's negative. And then when you plug in 2, you get 6. So it's positive again. Whoopsie. Try that again. Positive. All right. So now let's finish solving this. So it says we're looking for where this polynomial is greater than or equal to 0. So we're going to use the positive interval. So this was one of our answers. And then this is one of our answers. We're just going to connect those with a union symbol. So we get negative infinity to negative 4 bracket union bracket 1 to infinity. And there's your answer. This is, they use a different method. They make a little table in your homework system and in your textbook, but I think this is a little bit easier. I forgot to number this question. This was number 6, sorry. Forgot to number that one. All right, we're going to do one more example together. This one is nice and easy because it's already factored. It says, this is be number 7. Find the solution of the following polynomial inequality. Express your answer in interval notation. So we have x times x plus 8 squared times x minus 5 is less than 0. All right, so step 1 is to find the solutions or find the zeros, find the x intercepts, same thing. So we're just going to go off to the side here and we're going to set this whole thing equal to 0. All right, and then it's already factored, so I can just go ahead and set each piece equal to 0. Now, I have set x plus 8 squared equal to 0, but it does not matter because if you take the square root of both sides to get rid of the square, it's just going to end up with x plus, the square root of 0 is 0, so it doesn't change anything. So I'm going to get rid of the parentheses and the squared. All right, so here's my 3 zeros. We got 0, negative 8, and positive 5. All right, so I'm going to make my little number line. Click the wrong one. There we go. All right, so mark your numbers in the correct order. So -8, 0, and 5. You can write the intervals up underneath. That's what I think is good to do. This is a less than, not a no equal to under there, so we're going to use parentheses on all of our intervals. Right, now I'm going to go in and pick a test point. Again, I'm just trying to pick something that's easy to plug in. So a number between -infinity and -8, let's just do -9. -8 to 0, how about -1? 0 to 5, we'll do 1. 5 to infinity, we'll do 6. So I'm just picking those kind of randomly. Trying to just pick easy numbers to plug in. All right, so let's plug these in our calculator. Again, we can use that little table to make our work a little bit easier. So clear that out. Go to your y equals screen and clear this out. Type in your new function, x parentheses x plus 8 squared times parentheses x minus 5. All right, then go second graph to go to the table. All right, -9. So if x is -9, that gives you a positive number. All right, let's get our pen. Use a different color. All right, so this one was positive. -1, that's right here. That one's also positive. Sweet. Well, actually, my bad. We're looking for negative intervals, aren't we? We're looking for where it's less than 0. All right, and then 1, that's our next test point right here. All right, so go down to 1. You can see it's right there. It's negative. Okay. And go down to 6. 6 is also positive. Okay. So we are looking for, I don't know why it wants to make the screen so big. Let's see. Okay, that's a little bit better. All right, so we're looking for where this polynomial is negative or less than 0. So that is the only interval that satisfies that quality. That's the only interval where we got a negative. So our answer, our solution, is just the interval 0 to 5. And you're done. All right. I really like these polynomial inequality problems. I think they're kind of like a little puzzle. So make sure you get plenty of practice with these. You will see one of these on the test. And if you have any questions over section 5.1, please let me know. Otherwise, I'll see you guys soon.